Pre-algebra lesson 16. Now we're going to start learning about exponents. As you remember, multiplication is a faster form of addition, and so exponents are in fact a faster form of multiplication. Exponents are represented by this little tiny number up here, right? So if I zoom in here, well, that was too close. Let's see here. Alright, so if I zoom in here, what we have here on exponents is we have two parts of the number. We have the normal number, which we see is 4, right? That's normal. We're used to seeing numbers like that. But this little tiny number up here in the corner, that's called the exponent. When we're dealing with numbers, the normal number that we see, or the one that's the normal size, is referred to as the base number, and the little number, the exponent. Now, what's happening here is this little number, this exponent up top, tells me how many times I need to multiply the base number by itself. Right. Now, exponents are read in a specific way. We see some examples right here. For example, to the second and third power is read as squared. Right. So we could say this is 4 squared, or we could say 4 to the second power. Here, if we have something to the third power, we would say cubed. So this is 2 cubed, or 2 to the third power. Once we get past 3, everything is just called the power. So 5 to the fourth power, 10 to the fifth power, etc., etc. I'll keep referring to them that way, so the only special names you really need to learn are squared and cubed, and those will come naturally pretty quickly. Now let's go how to solve these. So let's go to an example problem. Here we have 2 to the power of 6, or 2 to the sixth power. Right, now remember, I said the exponent is telling us how many times we multiply the base number, and that's how many times we multiply the base number by itself. So when I say 2 to the power of 6, what I'm actually saying is 2 times 2 times 2 times 2 times 2 times 2, or 2 multiplied by itself 6 times. Right? Now when we're solving exponents, it's good to write down all of the numbers, especially when you're first getting started, because it's very easy to forget one, especially if you try to multiply in your head. So don't try to multiply in your head, just be patient, write down all the numbers, and keep track of them on paper. I like to use this way, this little connecting method with a line. So I'd say 2 times 2 is 4, times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2 is 64. Now, if you're not that quick on mental math, that's fine. You can go ahead and write an algorithm. Like if you got stuck on 16 times 2, go ahead and go off to the side, write 16 times 2, carry the 1, and hey, you see it's 32. Right? So if you can multiply in your head accurately, keyword being accurately, then you can go ahead and use quick methods like this. Right? If you can't, then go ahead and use a good old-fashioned algorithm. But the final answer is going to be 64. So 2 to the power of 6 is equal to 64. Now, one thing to notice about exponents is the numbers rise very, very quickly, and that's something you'll see pretty often. Now let's go to the next one. This is 1 cubed, or 1 to the third power. So what this means is 1 times 1 times 1. 3 ones. Okay? So now you 1 times 1 is 1, times 1 is 1. So 1 cubed equals 1. And that's the funny thing about 1, whenever you bring it to an exponent. 1 to any exponent will always equal the number 1, because 1 times 1 is always going to be 1. So that's one number that doesn't change at all. But as soon as we go up to a number like 2, the number rises very, very quickly. All right, let's go to our last example, which is 5 to the power of 4. So I'm going to go ahead, this isn't our last example. This is our second to last example. 5 to the power of 4. 5 times 5 times 5 times 5. 1, 2, 3, 4 times. Okay. So from here, 5 times 5 is 25. 25 times 5. Let's see, if I count this by quarters, I can get it pretty quick. So I can do 25, 50, 75, $1, and then $1.25, or 125 for 5 quarters. And then I have to do 125 times 5. I better multiply this to make sure I don't make a mistake. 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2 is 12, carry the 1. 5 times 1 is 5, plus 1 is 6, 625. So 5 to the power of 4 equals 625. All right, so those are our basic exponents. That's how we compute them. Now, what your book is going to do is they're going to give you problems like this one, like letter D, where letter D says, write 3,240 as a product of prime numbers using exponents. So what they mean by using exponents is anytime we have numbers that repeat, instead of writing the number multiple times, like here, instead of writing 2 times 2 times 2 times 2, I can abbreviate it using exponents. So I'm going to show you how to do that right now. So if we have the number 3024, first thing I want to do is factor it into prime numbers. I'm going to go ahead and use a factor tree because that's my preferred method. If you want to use a tower, a division tower, that's fine. So I'm going to have 3,240, and I know that's an even number, so I could divide it by 2, but I also see it ends in 0, so I could divide it by 10. I think that's a little bit more beneficial because I know that 3,240 divided by 10 is going to be 10 times 324. So when you're factoring large numbers, look for easy numbers like zeros and fives. So then now that I've got 10 and 324, I know that 10 will factor into 2 and 5, and those are both prime. So I'm going to go ahead and circle those so I don't forget about them. Now I have to factor the number 324. Okay, let's see. This is a tough one. Oh, hey, if I add 3, 2, and 4, 3 plus 2 is 5, plus 4 is 9. 9 is divisible by 3, so I know this can be divided by 3. So I'm going to have 3, and if 3 goes into 3 one time, 108. 3 and 108. So I divided in my head very quickly to save time on the video, but if you can't divide that in your head, go ahead and use an algorithm. It's a difficult number to divide mentally. Right? So 3 is my prime number. Then I have 108. Now, if I've memorized my times tables, 108 is a great number to see because I can recognize it. I know that 9 times 12 is equal to 108. Wait, is it 9 times 12? Yes, it is. 9 times 12 is equal to 108. So I have 9 and I have 12. I'm at some good small numbers that I know how to factor. So then 9 is 3 and 3, and then 12 is going to be 3 and 4. All the 3's are prime, so I'll circle all of those. And the number 4 is not, but 2 is. So I factor 4 into 2 and 2. And now I have all my prime numbers. I've successfully done the prime factorization. And normally I would take these numbers and I would write them in order. So I've got 1, 2, 3 2's. So I'd put 2.2.2. And then I've got 1, 2, 3. I've got 4 3's. So dot 3, 3, 3, 3 for my 4 3's. And then I have 1, 5. Dot 5. Now, normally I would be done. I'd put a box around this and my answer would be complete. But the problem says to write it as a product of prime factors using exponents. So the way I'm going to use exponents is I remember that the exponent is the number of times a number gets multiplied by itself. So if I have 2 being multiplied 3 times, I can just write 1 2 with an exponent of 1, 2, 3. So 2 cubed. Then I put a multiplication and I see I've got multiple 3's. How many 3's do I have? 1, 2, 3, 4. So I can put a base number of 3 with an exponent of 4 because I have 3 being multiplied 4 times. And then 5 is all by itself, so I will just put times 5 with no exponent. And that is my final answer. If you have any questions, let me know on the school website, and I will see you in the next video.